welcome to today's webinar, Accelerate Your Digital Transformation. Build apps quickly to consolidate, monitor, and analyze your data and processes. With your presenters, Remy Duquette, Vice President of Industrial AI and Data Center Clarity, LC, and Chris Blake, Director of New Product Development for Maya HTT. My name is Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and I'll be your moderator today. First, a few housekeeping items to cover. Today's webinar will be recorded, then available for on-demand replay on engineering.com. For attending our full live session, you'll receive a PDH certificate within 48 hours. If you have any questions, you may submit directly in this webinar interface, and we'll try to address all questions during Q&A. Now, without further ado, I'll pass it over to our first presenter. Remy, over to you.
Thank you, Maria, and welcome everybody. So as Maria introduced us already, I'm Remy Duquette, Vice President of Industrial AI at Maya HTT. Maya HTT is a software-driven engineering solution firm, and we have been awarded this year #1 worldwide partner from our partner Siemens, a great company that we work with over the years. And we're, a bunch of passionate engineers like you are all on the call, I'm sure. 75% of us are scientists and engineers, and we developed 30 plus solutions over the years. We started in space, but we've evolved significantly, and today's topic will be kind of a nice, perhaps refresher for all of us. Our clients are quite diverse. We supply clients, of course, that put satellites in orbit, so we provide solutions to those satellite and aerospace companies. We provide solution also for automotive, people building and manufacturing lithium batteries for electric cars and electric buses, all the way to providing logistics and artificial intelligence for people delivering tomatoes and other goods. So as you can see, we serve a very diverse set of clients worldwide. And so hopefully what we've learned over the last 30 years as a company will serve you well moving forward. And we really accompany our clients from beginning to end, right? From the design of the products to the simulation, the virtual simulation, computational aided engineering, CAE type simulation, CFD simulation, computational fluid dynamics, all the way to manufacturing simulation and logistics, and then more recently in the last 7-8 years on the industrial IoT and applied artificial intelligence, machine learning, deep learning. And today we will extend that and amplify that with no-code, low-code solutions, as my colleague Chris will present. And we of course provide out-of-the-box solutions, but also very automated and custom-tailored client-made solutions, and all the way to the lifecycle management. So really, that's the full wheel of what we produce. But today, the focus of this webinar is really to help you define a practical digital roadmap for your engineering and manufacturing application. So we're not here to sell your product. We're here to guide you through road mapping and strategic planning for your journey into Industry 4.0, industrial IoT, and digital transformation in general. We're going to cover topics like identifying proper sources of your data and how to access them in an operational fashion and make sure that it will be operational once you deploy the solution, and really helping you turning your collected data, whether it's real-time data or manual entry data or lifecycle management data or design data, into really information and things that you can, actionable information that you can really act on and make better decisions with. So we'll look at some IoT platforms such as Siemens MindSphere. We'll look at no-code, low-code applications developed with Mendix to accelerate your app development, and look at some examples of industrial analytics and artificial intelligence used in the manufacturing space to give you a good flavor of what you can expect these new technologies can deliver for you. So as a summary, a high-level summary of just that piece of Industry 4.0 and digital twin platforms and capabilities, we've deployed solutions in many areas. There's Signal Explorer, so a MindSphere application, so industrial IoT type platform where we built a nice app for exploring smart signals from and telemetry from your assets. We've developed an outlier analysis and anomaly detection for high dimensional outlier analysis, a great app for, even just use as cleaning data in some manufacturing environments in real time. Digital twin examples will show some, smart buildings as you see here on the left, the bottom. Chris will cover, I'm going to steal his thunder on the Mars rover, amazing example, and a bunch of other IoT and Mendix app, which Chris will provide. And we really focus on practical AI ready workshop and industrial AI consulting and applications where we can help you get started, augment your teams, and really work with you. Now, as a level set, I thought I would start with kind of giving you a little bit of the value that Industry 4.0 is shown to be bringing over the next 15 years. So from now till 2030, of course, we're all living through exceptional times right now, but at some point we all understand and recognize that over the next few years, things will get back to normal. And if you look at the GDP incremental value of Industry 4.0 alone, and these are various numbers that we've collected from various analysts, you have the value of digital transformation and Industry 4.0 is just significant and enormous in all regions of the world. If you're in North America, it's quite staggering. That $6 to $8 trillion will be generated by applying Industry 4.0 technologies to really increase the value of what you produce and the efficiency of it. So based on that, I wanted to kind of make this webinar a little bit interactive, so it's kind of fun for you guys. So first poll question will be like, what would you estimate your digital transformation Industry 4.0 level of maturity is? And we've provided kind of a multiple choice. 1, I have not seriously started. 2, started a little bit of exploratory and proof of concepts. And 3, implementation projects. And 4, it's part of our DNA. We do it day in, day out. So Maria, I think I will turn it to you for that first component. We see the numbers are starting to come in, so please go ahead and enter your numbers in there, and I'll give it a few more seconds. It's very interesting. We see that about half of you have not seriously started your journey, which is totally normal. And about 50%, if we add the later 3, are on their journey to implement Industry 4.0. So this is actually quite in line. If you look here, that was my pre-made PowerPoint answer that 50% of our clients say they have started POC of implementation phases or beyond. And so it's very in line actually with the results of the poll today. 50% of you have said, not started the journey, and then 29% you've started POC, and 14% implementation projects, and 8% it's part of your DNA. Actually, the 8% is actually quite interesting because that's first time. Normally, we get about 4 or 5%. So 8% is already a big jump that some of you are well on your way in the digital transformation Industry 4.0. And historically, for the 50% of you that have not seriously started, historically, there are really good reasons that we've seen with many discussions with our clients as to why digital transformation has taken so long to get going in some areas and some industries. And a key initial step really is when you look at the cost benefits, and it's kind of the 2 inverse pyramids that you see here. And while it's essential to, of course, instrument and procure sensors and put the data infrastructure and pipeline in place, Today, we have new technologies that will fast track this. And I guess a key element, a takeaway from this presentation, hopefully, you'll see some ways to reduce really that initial cost, right? And yes, it does come with getting benefits earlier and having less costs. And some of these are the new sensors, the new IIoT sensors, industrial sensors that you can deploy on a mesh level in a much faster and much more cost-effective way than you used to be. So in the early days, just the instrumentation of your manufacturing plant or your processes or your assets that were deployed worldwide was quite staggering. So, and the benefits came later. So, to justify their ROI, there was difficulty to get going. But now these are really, kind of moving forward the process of digital transformation, and you get still in the end an increased level of benefits because you start early and faster and in a more agile fashion. And Chris will talk about the low code, no code, which is yet again another accelerator of those benefits, and we'll see how that applies to the processes. So here I wanted to kind of show you how to get started, right? We talk a lot about getting started. And for the half of you on the call that, have not started yet. So, the first thing we would say is if you look at your maturity level, the first thing that you need to kind of look at is your readiness assessment and look at the business use cases where you could eventually apply new technologies. But don't start with, saying we're going to use AI. Where are we going to use AI? Do it the reverse way. Look at your current pain points. Where do you have problems? Do you have logistics problems? Do you have quality assurance problems? Do you have delivery problems? Do you have design issues? Do you have there are all sorts of problems, and really those use cases, those business use cases, should drive the adoption of technology and not the reverse. And so, based on the use cases that you'll list, and we'll go through a little bit of the process to do this here, you will look at the data availability in support of those use cases to get started and identify the gaps, the bias in the data that you might have, and then move forward to perhaps a discovery phase, which is a little bit longer, where you target some specific use cases and deploy in operation and look at more techniques and cause and effects. And then you go into enablement, where you really start deploying data infrastructure and where you can, really look at Industry 4.0 from end-to-end type chain and value chain. And then you make this over time into an Industry 4.0 and AI as a culture within your firm, where everybody thinks about these things when they get started. So yeah, the end-to-end.
Yeah, and if I may, Remy, I'd love to draw a parallel in this slide to some of the projects that our attendees may already be familiar with. Anyone who's gone through like a workflow automation project, or perhaps a product lifecycle management deployment project, you probably would be drawing parallels between what we're seeing here and how those projects evolved. You really need to start again with the business use cases, as Remy you were saying, like what data do you want to store in your PLM system that's going to benefit your efficiency? What are inefficient about your current processes, and how can like PLM and workflow automation improve things and provide value? You really need to define those before you dive in and do actual implementation. You need to identify the high value pilot projects so that adoption is going to be more successful. So there's really much for any of these enterprise type initiatives, the pattern is very much similar. Yeah,
absolutely. And as I said before, we're very passionate engineers and practical people at Maya, and we like to take very sound procedures and processes and apply it. And if it was true for PLM, evolution, looking at the business use case first and then the applying technologies later, we apply the same principles here, core principles, with industrial IoT sensor and meshes and artificial intelligence, machine learning. So as you'll see throughout this presentation, we're very focused on practical use cases and practical implementation of these new technologies that do have significant benefits. And you need to move beyond the hype of all some of the stuff that you see online, but you have to really look at the practical applications for you. In terms of AI and Industry 4.0 or IIoT type success, we really have identified seven elements leading to that success. And again, I'm going to harp on this. The business use cases, identify the source of value of how where your pain points are, and really focus on is that technology applicable to solving this problem or not. And then you go down the food chain, right? With the data infrastructure in place, do we have IIoT or data pipelines that we can reuse for an early pilot to try out the technologies before we go and deploy larger systems or across the board? And then you look at your data quantity in support of that business case that you've identified, the data quality and the control over the operational bias. Operational bias, I'll give you a very simple example. A lot of AI projects fail because of this, so take note. So when a technician is in front of its machine that's starting to show signs of failure, the first thing the technician will do is kind of slow down the regime of the machine to kind of figure out what's happening before the actual problem starts really happening. And so when you give that data set of real-time telemetry to a data scientist without looking at the operational bias in the data, the first thing you see is the AI or machine learning algorithm. What it will learn is that, hey, when things slow down, it leads to failure. So let's accelerate it instead. So you draw very wrong conclusions if you just look at data without its operational bias and the settings involved and the human in the loop in many cases. And really, artificial intelligence really to me is an augmentation of natural intelligence, right? So there will always be, at least for the foreseeable future in many manufacturing areas, even though it's Industry 4.0, and yes, it is there to help us automate many things. In the end, it will augment a human being and our abilities to deliver more value for the companies we work for. AI, and then you go down the food chain again, AI models and data pipelines, and operationalize these AI models. So keep track of the revisions, and when the AI models start, the performance metrics that you apply to them when they're operational, you track those performance over time to make sure that you can retrain them when needed, or when their operational rates or metrics of performance are decaying, and that happens often over time for various reasons. And then you look at the IIoT and the integration and the process and the culture changes that may be needed to really get all the benefits from the solution. So another poll question, based on that, and before we dive into some of the nice let's say use cases and how you define them, if you can go and start the poll on what are your top of mind and highest value use cases that you see for yourselves in industrial industrial AI or IIoT. So you can check all that applies. We'll see over time how this kind of jives with what we're seeing in other people, and what they're focusing on today for their use cases. I see it's quite interesting. There are many people with machine downtime and just-in-time maintenance. I'd say reduce product quality is a big one. Yeah. And the last one, optimize machine effectiveness. Yeah, a lot of manufacturers are all gung-ho about this, and for good reasons. That's where they get their machines maximum output. Well, it looks like we're converging here to good splits. So in terms of the ranking, I'll start from the top. So find machine downtime causes and run just-in-time maintenance. 54% people said that's a key use case they want to focus on. Reduce product quality issues is one of the two biggest one, so at 61%, which is actually a really good sign, and I'll tell you why in a second. And 28% increase first-time yield success rates. So, perhaps some, manufacturers are more focused on yield success rate than others. Here, 28% is actually quite good for use case lookout. And increase energy efficiency, 26%, so a quarter of you, and 61% optimized machine effectiveness. I think that makes a lot of sense. Well, thank you for your feedback here. And when we look at our clients that we've served over the years, about half of them, talk first to us about predictive maintenance and just-on-time maintenance and finding, root causes of these downtime and the maintenance of those machines and assets that they're using. And while this is clearly a very high value one, we'll see in the next slide that improving product quality might be a lower cost first item. And so the fact that you guys on the call, at 61% of you as engineers, said reduce product quality issues is a key focus and key use case is actually a great way to start from our perspective, from what we've seen over time. And again, back to getting started. And when we say, look at your use case and your business use case first, we're not kidding. We're really, wanting you to do that first. So when before you start a program like this in Industry 4.0, hopefully the ones that have started that process, the digital transformation process, have done this, and if not, please do yourself a favor and do it just to make sure that and validate that you've started on the right process and right use cases. So what we're trying to do is first you just list all the problems and the use cases that you see you have issues with or where you could gain significant value from. So whether it's reducing product quality issues, that's clearly with rework costs and other cost issues, or even sometimes recycling of lithium when you're manufacturing lithium batteries for electric cars. These things are very costly. So increasing first-time yield success rate, that would increase the value of your product. So over time you can gain, a 0.1% gain in yield success rate, first-time yield success rate can be humongous in terms of the value of the output of a manufacturer. Reduce end product performance and all this. So you just go down and list your use cases, and for each use case you kind of evaluate in a rough order first, right? You don't have to go in the details first, but at a high level, look at the value that you think this will bring. And if you can't articulate the value, put it low, because that means you probably don't really know. But if you do know and you have a good idea of how to frame that value, then you look at the time to implement for each of these use cases, and there you can leverage people like us or other consultants to help you kind of gauge how much time it would take to implement. And based on these rough order of magnitude of use case value and time to implement, you just put those little numbers of use cases in your matrix, and you draw your matrix like this. And then you start with the proof of concept in the right hand corner there, where it's the highest value at the lowest time to implement. So these are really the ones that you want to start with in your journey to digital transformation. And then you move up slowly for the ones that are maybe longer time to implement but still yield a significant value. And that allows, by starting on this bottom corner there, that allows people to do a quick cycle and a short time to value, and gain confidence in these new technologies. And then with these people slowly believing that, yeah, this makes sense, digital transformation, artificial intelligence, machine learning, deep learning, these new technologies are starting to help us. And yeah, it's augmenting my abilities as a human being, so I'm no longer scared of this thing. So now we can go and move beyond and create value for our enterprise And as the enterprise grows, so far what we've seen is there's always more people in the plant later when we go back after these are deployed successfully, because the value, once you can produce a lot more effectively, well, of course, you're going to want to produce even more. So you're going to need more people and kind of go forward with. So, or keep the same people, but deliver a huge amount more value for everybody involved. So anyway, that's our little view here. Now, as a specific example, application example, I wanted to cover a manufacturing quality issue. I'm glad that this was 61% of you said that's a good use case, because that's one that we always recommend, because it's typically relatively low-hanging fruit and can yield significant business results for the company. So we have this kind of 5-step approach, and I'll walk you through each of this step very briefly so that you gain an understanding of how you get started with such a project. So again, step 1 is always the business needs and the use case. So in the case of quality, you can look at in the case that we're talking here, we wanted to reduce the manufactured product quality assurance rejection rate because it was seen as being a bit too high. And there was also a performance variability of the end product. So after 10 or 12 stages of manufacturing and multiple sub-stages, there was a high rejection rate and a high cost of rework for these components. So we looked at different data sources in support of that business case and that business need. And what we found, there were 3 really sources of data. There was an IIoT system in place for real-time monitoring, and an historian that was in place, and an SQL database with all the manufacturing logs, and the ERP database where a lot of the financials and the source of raw materials from various suppliers were also in there. So based on manipulating these 3 sets of data, we were able to augment the data, validate the data, and make sure that it was ready for the middle aspects. So as we go here to the middle aspect, and again, it's a lot of details in this, so it's not really meant to be a slide that I would talk to. But in the end, just believe me, it's not rocket science, and yes, I am a rocket scientist. So here my engineers or your engineers can go to town here, and that's really not necessarily, I mean, it's a key piece, of course, and we gain a lot by looking at, in this case, 130 deep neural networks, and we optimize to, and we use all sorts of sophisticated techniques to get there. But in the end, the business need and the data pre-processing are the key that takes a lot more time to get to. But once you have the data pre-processed, then applying different artificial intelligence, machine learning to get there is not rocket science. It's a systematic approach that we can all go to town with as engineers. So in the case here that we were talking about, we essentially pinpointed after 4 of the 10, 12 stages of manufacturing that we could predict with a very high accuracy, almost 99.52% accurate, that 78% of the problems were essentially occurring before the four first stages in manufacturing. So after 4 stages of manufacturing, the technicians on the machine would get a red flag to remove some of the components from and put them aside and retest them separately. So that kind of flowed down very simply. And then we did the validation with subject matter experts. So the people that knew exactly day in, day out what was happening in their plant, the product itself, all the parameters, and we worked with them to understand their sources of failure and the cause and effect that we were finding through applying deep neural networks on this problem and finding the quality issues and the causes, not just correlation, the real causes to make sure we avoid the problem in the first place. And then in the end, when we look back, we need to make sure that metrics report back on the step 1 in terms of business needs and use case. In this particular case, it was quite even if it was a low-hanging fruit and a relatively fast deployment, the 400K per year in savings was quite a good example of a successful first project, proof of concept that reliably give you real tangible results in terms of business that you can track back again to the step one, which was let's define our business needs and our issues first, and then apply the right data and the right technologies to that problem, and validate with subject matter experts as the step 4, and let's make sure we track and put metrics in place to see that the AI results are actually attained, and everyone is happy. And that entire process of that industrial AI project is probably about 3 to 6 months when you look at that process.
Yeah, and I guess if I can just re-emphasize what we've been saying over and over again is that you'll notice again that the process here is bookended by tying things back to the business needs. That's not an accident. As much as Remy and I were engineers and we love to dive into the nitty-gritty of the AI algorithms and stuff, all that effort can very much go for nothing if the use cases and benefits or perceived benefits aren't defined up front so that you can measure the results when you're finished your project. Basically, you want to turn it into value. So again, it's not an accident that we're saying business on both ends of this process here.
Yep, absolutely. So with this, Chris, I will turn it to you to continue our great discussion.
Yeah, but I'll leave you to keep clicking ahead for me. So apologies if I keep saying next here as we go forward. So now we're going to move into some applications and use case examples, just kind of to tie things back into, again, this topic about defining the needs of your business. So hopefully those of you who haven't yet gone on their journey towards Industry 4.0 and IoT, some of these examples will spark some interest and make you start thinking about, oh, what I could do differently in my business. So I'm actually going to go back to the preventative maintenance topic first. That was certainly one of the areas of interest according to our previous poll. So certainly what we find is that manufacturing companies and industries, they want to automate their processes for sure to remain competitive. At the same time, very often the maintenance schedules that they have for the equipment in their plants may be on fixed schedules, or they're more ad hoc in the sense that they're only triggered when something forces them to perform maintenance. For example, if machine breaks down, that of course leads to costly downtimes and lost revenue. So that's something that ideally you want to avoid. So preventative maintenance, getting ahead of things and planning out the most strategic point to schedule maintenance so as not to do it too early and waste money, or do it too late and lose money, is kind of key. So what enables this use case is very much an IoT platform, such as Siemens MindSphere, per the logo that we have on this screen. So the IoT platform, or MindSphere, collects data from your manufacturing assets and allows you to monitor and visualize and process the data on a cloud platform. But to make decisions on when it is a good time to schedule your maintenance based on the inputs that you're getting from your assets on the shop floor, it involves transforming that data into useful information and insight. So part of that involves identifying, extracting, filtering out any of the extraneous data before you even attempt to process that. And actually, machine learning algorithms for outlier detection can be very much useful, very key to that process. And as a bit of a sidebar to that end, we're going to be holding probably a subsequent webinar specifically on the topic outlier detection. So stay tuned for that. But there are other ways as well that are important to manipulate and transform that data. So if you can go to the next slide, Remy. Yeah, so there are other ways to process the data depending on the application. That brings us to an example application that we at Maya developed on the MindSphere platform called our Smart Signal Explorer. So when you're thinking about, in particular, rotating machinery, some of the things that you might want to track to understand the current performance of the machine includes like natural frequencies of vibration or the consistent rotational rate of the machine. And in order to extract that information from raw signals that have been instrumented and thrown up into the cloud, you actually have to implement, data pipelines of signal manipulations in order to do that. So that's what this app is meant to accomplish. So it's accessing the IoT data that's available in real time from the MindSphere platform. Allows you to define a sequence of math functions that, in this little example here, can extract through filtering and fast Fourier transform the spectrum of the signal, and then from that you can extract the natural frequencies. Now, how is that useful in terms of preventative maintenance? Well, if you compare either distinct chunks of data extraction or an ongoing automated extraction of this information, if you see shifts in the natural frequencies or shift in the rotational rate, that might indicate performance degradation. Then you can tie alarms to that if you want to, and that can be a trigger for your preventative maintenance, as opposed to waiting for the machine to go down entirely. So it's this type of data manipulation that is enabled by having data accessible on a cloud platform where it's easy or relatively easy to implement these pipelines and implement these apps that can manipulate the data. Then on the next slide, oh, sorry, there we go. So yeah, Remy stole my thunder earlier, but this is kind of a cool example. Certainly cloud IoT platforms like MindSphere allow you to visualize the data that's coming in graphs, in plots, tables, stoplight dashboards, that kind of thing. But very often the true engineering context is needed to gain real insight into whatever problem is that you're trying to solve. So in this use case, or that use case is shown here actually, where we developed an application to extract and process telemetry data and present it overlaid, this time on top of a digital twin of the Mars rover. So when temperatures decrease or power consumption increases, being able to visualize that telemetry in the context of the digital twin allows engineers to more easily understand and diagnose the problem. You can imagine that if a whole bunch of temperatures are increasing in one location, or only one temperature is spiking in one location but nowhere else, you would interpret that differently. So having that spatial context is useful. And at the same time, the digital twin of the Mars rover can be simulated using CAE techniques, thermal or well, mainly thermal if we're tying something that's already deployed out there in space. The simulations can be used to corroborate the hypotheses that are gleaned from that telemetry data. Now, these last two examples are of applications that were developed by us at Maya using the coding languages that are available on the different platforms. So in this case, MindSphere and Siemens's NX SimCenter platform in the case of the rover. But very often, business needs require a much faster turnaround time in order to reap the benefits of these apps, of these applications. So that brings us to poll number 3, which is on the next slide.
And Chris, if you allow me, I will jump in very briefly here, just because
You worked on this project, right?
Yeah, 15 years ago. So now you're giving me flashbacks of these real-time telemetry. And just for the participants, when we talk about real-time telemetry, in the case of a rover that's on Mars, as you can imagine, the latency is a little bit more than what we're having today, right? When you're an engineer and you get essentially a data dump every 8 hours of the last 8 hours, having the digital twin of that rover in front of you with the articulation and the motion of the joints and the wheels and everything, and the sensors of temperature sensors and other sensors, it makes a huge difference. And I'm going to make a very short parallel to the exceptional times that we're living through right now with COVID, and having access to that digital twin and being able to see in 3D what's happening at your plant or on your assets that are remote now, and we're all remote, and that might be fine. We might get back to offices in a few months, but in the end, you can see that these digital twin serve an increased value and purpose. So from that standpoint, anyway, I just thought it would be an interesting nugget here of history that on the Mars rover, you get 8 hours of real-time telemetry every 8 hours, and you need to replay what's happened in the last 8 hours, and you have 8 hours to do it. So it's kind of an interesting use case, at least from a remote monitoring perspective and understanding and troubleshooting from afar.
Yeah, very cool, very cool. So just getting on to the poll question, and I guess we can post that now. So in terms of faster turnaround times, we wanted to kind of poll the audience and understand, so how do you manage the development of your custom applications? I'm sure in your companies, there are certain applications that need to be developed. So are they managed completely by internal IT? Is it a combination of internal IT and shadow IT? Are these projects being outsourced to external third parties? Or have you kind of embraced this citizen development using no-code, low-code platforms? I'm already seeing the polls come in. So we had a spike initially in the managed completely by internal IT, but suddenly shadow IT is starting to win. Oh, and they're, yep. Well, it looks like it's going to be a combination of the first two, the majority of your custom developments, which, to be honest, is not that surprising. When it comes to anything enterprise-wide or corporate, control typically wants to be maintained within the IT organization, and there are very important reasons for that. I'll come back to it in a moment. But sometimes that's perceived as not efficient enough, and so that's what leads to shadow IT. So ingenious or enterprising groups within the business, develop their own apps themselves without necessarily the input or structure that the internal IT organization affords. So that was interesting, not very surprising, to be honest. But let's get a little bit more insight from you guys. We'll go to the next poll question. So what is the average delay that you are seeing between the business needs and the deployment of these custom applications in your organization? So given the fact that often it's being routed through IT, so it looks like the middle two answers, but looks like 6 to 12 months is sort of winning the poll battle right here. So certainly not a negligible amount of time to get these business necessary applications deployed to the broader organization. Yeah, so it looks like we're stabilizing here. Yeah, and it looks like about 43% of you have said 6 to 12 months, 14%, so a total of, was that 57? Yeah, so well over half are talking about 6 to 12 months plus of time to get these applications deployed. And happy to see that 15% of you or so are getting them done in 1 to 3 months. So that's good, but the vast majority are taking a fair bit of time. So again, that's not surprising. I mean, we've seen many IT organizations having 12 to 18 months of business app backlogs, which is important when it comes to turning value out to the business and to your clients as quickly and efficiently as possible. So this leads us to the subject of no-code, low-code platforms, and we're going to focus on the Siemens platform known as Mendix. So just to get into some more details, we often observe in companies an imbalance or a gap between the demands of the business and what the IT organization can actually produce. The business has needs that they have now, we need it now, and it's mainly because they are strategic. You know, they might be wanting to bring new ideas and products to market quickly to capture market share, or they want to remain competitive or stay competitive by reducing costs and streamlining and automating operations internally. The problem is, as talented as IT teams are, we're not trying to disparage IT teams at all, they struggle to meet the demands. And quite rightly, IT wants to stay in control and not allow numerous shadow IT teams to crop up, because they may not be leveraging corporate infrastructure efficiently or properly, or there might be security problems or maintenance problems. You know, that's the way that legacy systems crop up and get entrenched into the business processes. IT also follows useful and necessary procedures like agile, DevOps processes, but they might struggle to deploy that on a broader scale. So another thing is, when the business does leverage internal IT, very often the requirements are just thrown over the wall. And then 6 months later, when the business application has been developed and completed, it may come back not quite meeting the business expectations. That's especially true if IT ends up outsourcing it to an offshore firm to do the developing. There's a lack of ongoing collaboration. And Mendix no-code, low-code is meant to try and address those very pertinent issues as a way of closing this gap. So while still working off the same core infrastructure, what Mendix allows is different company profiles to contribute to the application ecosystem. Citizen developers who are for sure the subject matter experts, know their applications really well, what they want to achieve, but they don't really know how to code. And so they're not going to be the ones who can do the C# or the JavaScript to get their apps built. The way they would interact with a platform like Mendix is to interact at the UI-driven no-code level, so they can build their apps quickly and efficiently. But as SMEs get more and more aware, they may interact at the low-code level, still implementing logic and microflows from a purpose-built development environment. And then you can still have the professional developers from IT continue to code either complete apps or component widgets that can be in turn leveraged by all the citizen developers. So everybody can interact with a no-code, low-code infrastructure like this. Mendix really enables collaboration and brings citizen developers into the development cycle. It enables you to push and build cloud-native applications that much faster. But that's not all. At least with the Mendix platform, you end up getting native support for different channels and devices. Whether you want to use it on a PC, phone, tablet, you get responsive apps that just work right out of the box. These apps would sit on top of your data using pre-built connectors, for example, to your PLM system like Teamcenter, an IoT system like MindSphere, ERP like Oracle, SAP, and because they're part of the same Siemens family, the deep integrations with the Siemens portfolio really allow you to leverage the fact that there's a digital twin behind there, so you can tap into the digital twin using these connections. And last of all, it doesn't force you to lock into a Mendix into a cloud strategy. You can deploy these apps onto the Mendix cloud, to your own private cloud, so public cloud, sorry, or even on premises if you want. So, you guys can start using Mendix right away, or you can call on an expertise of a partner like us at Maya to kickstart your first IoT related app development or deployment, and then subsequently you can take over from there. So that's the spiel. Now, just to give you a flavor of what's possible, let's look at a couple of examples that we've worked around. So let's talk about the manufacturing shop floor, and particularly when we're talking about small machine shops. A number of challenges can be faced. Last minute changes might crop up on the shop floor because they're not being tracked well, and there's wasted effort in order to deal with those. There might be a lack of visibility into the tracking of problems. There might be inaccurate, inconsistent inventories or records of inventories. Planning might not be sufficient, and so there's a little bit of disorganization on the shop floor. Sometimes you have isolated systems of record. Your ERP is one thing, your PLM system is another thing. Production planning and scheduling, quality management are entirely different things. And sometimes they're not actually formal systems. They might even all be Excel based. So there's difficulty keeping those Excel spreadsheets up to date. And then there's this concept of a job traveler. A traveler is a work package that lists the bills of materials and that assigns the specific machines, operational steps, and quality assurance checks that need to be logged as the billet, the thing that you're trying to manufacture, is routed around the floor. Very often what we understand and see at these smaller shops is that these travelers are entirely paper-based, which is quite astonishing when we're talking about digitalization, getting things up on the cloud. Things are still paper-based in practicality. So a lot of time is wasted compiling and printing this information and make sure it's up to date. So that, on the next slide, is where an app that's based off of Mendix can come into play. The use case is to build an app that consolidates all of that info in one place. Now, I'm not talking about replacing the individual systems of record, because those might be validated and trusted, especially when we're talking about quality management systems, but rather having a way that integrates and compiles the information for the shop floor technician and push any sign-offs or notes back up to the systems of record. Mendix has these connectors to ERP, PLM, even directly into Excel that would enable a digital traveler. And the value of this kind of app is that it eliminates non-value added time needed to compile and print all this information manually, and it gives the technicians on the floor much easier access to the information from like a workstation that's there, or if you're getting fancy, a tablet that's available on the floor. So just getting into a little bit more detail on the next slide, you can incorporate and monitor IoT data that's been instrumented and collected from the machines themselves, like what tools loaded, what is the current rate, what is the feed and speed, all that kind of stuff. You can expose inventory accounts if those are available as well. Like you said, I was saying before, statistical process control. You can collect data and feed it back into the QMS system. You can also digitally display the work order instructions. So instead of having a grubby piece of paper, the technician can look at his screen and see the actual work instructions that came out of the CAM system or the PLM system, and know what he needs to do in the next step of the manufacturing route. And you can see there's a little screen capture of the Mendix app that's showing this example. It's NX CAM work instructions in a nice web interface. And these are the instructions that need to be executed by the technician. I'm running out of time, so I'm going to go a little bit quickly onto the next slide, which is another example of Mendix app, but this time we're connecting IoT and the digital twin, in particular simulation digital twin. Here the IoT platform collects data. Oh, just go on back because I want us to see the, thanks Remy. We want to, the IoT platform collects the data while a real-time outlier detection algorithm is actually processing the data for any oddities. So you see a few screen captures on the left of how those outliers are processed and presented. So when a cluster of unusual occurrences or outliers is detected, say like on an asset such as the pump that we're showing on the screen, the measured attributes can be fed as an input into a digital twin of that asset. So for example, we might have a digital twin simulation model, a thermal flow model or vibration simulation model that can be launched directly from the Mendix app. The digital twin produces the outputs that provide additional insight into the state of the asset, such as an internal state that cannot actively be measured by IoT sensors. CAE expertise is not necessarily required because the digital twin already exists and has been validated by subject matter experts. The app just provides a streamlined interface to extract information from that digital twin. And so we're seeing here the inputs coming from the outlier detection algorithm and the results coming back that could give you additional insight beyond what those sensors are providing. And on the next slide, we see that we can run simulations from IoT. That's another advantage by having it through a web app that's hosted on the cloud, either an internal cloud or an external cloud. You can run these simulations, do these validations, do this cluster understanding and processing from anywhere, from any platform. And returning back to one of the earlier use cases that we talked about, preventative maintenance, having this additional insight into what's going on inside of the asset via the digital twin can help inform and schedule preventative maintenance and prevent unnecessary downtime. So hopefully a few of these examples have inspired you on how you can grab those low-hanging fruits and hopefully start you off on your digital transformation journey. So just some of the key points to remember from the discussion today: the value of digital transformation, how you quantify it, tying it to your business needs, and just in general, the value that the industry is seeing from Industry 4.0 and IoT. We talked about the steps in your digital transformation journey, harping admittedly on the fact that we're tying it back to value and business use cases. The prioritization of value using that heat map matrix is a very useful tool, simple but useful tool. And then we, in terms of the key use cases to remember, we talked about AI, industrial machine learning, industrial IoT, low-code, no-code development, and the digital twin. So hopefully this was informative, got you guys thinking. If you have any questions, now's the time. But just remember, we've got more webinars coming up. So if you want to sign up and listen to those or monitor the things that Maya is up to, we have an events page. You can see the webinars that are upcoming. So with that, just want to say thanks. Thanks a lot for listening. And yeah, we'll try and answer your questions. And we have a few minutes left. We'll probably go a little bit over, but yeah, much appreciated. Thanks a lot, guys, for listening.
Thanks, Chris, and thanks, Remy. We do have a few questions here. The first question is process mapping and modeling a prerequisite to identify pain points?
Maybe.
Yeah, I wouldn't mind taking that one. I'd say, I would say yes in part. A lot of process mapping, if you have the infrastructure in place internally and the resources in place, can be done by your company. Process mapping is an exercise where it's not necessarily the outcome, like having a BPMN chart of all of your processes mapped out. That's not the takeaway. The actual exercise elicits people to think about where the inefficiencies are in your process, and actually get you thinking about what's potentially going wrong or costing us money. So, in my humble opinion, I would say that process mapping is a useful tool to sussing out the areas of value on which you can implement IoT Industry 4.0 projects.
Awesome, thank you. While defining digital transformation roadmap, how much of the organization foundation capabilities are important to assess?
Well, and so far, I'll take that one, Chris. So, insofar as you're setting out to apply technologies that potentially can influence and change the process by which you conduct your manufacturing, or look at your assets or sell your after sales services, digital services. There are clearly assessments of which stakeholders certainly will receive the information, how they will receive it, how they will act on it. So yeah, there is I think a good level, as we said, as one of the key success is that change management and the impacts on the people that will receive the information and how they need to act on it. And so if you can figure out upfront who's going to be impacted and how, and have them participate in the digital transformation, whether it's Industry 4.0 with IIoT type sensors and information that will be coming to them, or if it's artificial intelligence, deep learning, machine learning, to help them make better decisions and what to tweak on the machine to make it better over time. You better have these main key stakeholders as part of your definition and process. So yeah.
Thank you. These projects look very similar to Six Sigma projects. Can you tell us what are the main differences?
Chris, do you want to take it, or I can jump on it?
It's up to you. Go ahead.
Okay, so I mean, from Six Sigma projects, they do look very similar. And Six Sigma has been in place for a long time. So how you apply Six Sigma to these projects is really, I would say there are lots of parallels, but there are key differences in let's say certainly the agile timeline how you're going to deploy those technologies. So the early portion of tying it to business use cases and defining all this data access and cybersecurity issues and all the, let's say, infrastructure that goes around these projects is a very, and how you define which project to start from, right? The low-hanging fruit type thing, which is really what Six Sigma is all about. That is very, very similar. Now, in terms of the downstream, how you apply it, the agile frameworks that you may need to put in place, especially if you use or leverage things like Mendix to deploy the apps to provide the information and the smart information to those technicians or engineers, then that is, I'd say, a little bit of the few key differences with the Six Sigma approach.
Awesome, thank you. Now this next question is kind of a 3-in-1, so bear with me. The digital twin that is being talked about, is it a mere simulation of the physical process, or are we also using connection with actual data and then tuning our model based on that, and also using the digital twin to suggest operation parameters? Is there a feedback loop between actual and digital twin? And please clarify which tool should be implemented.
I'll start off.
Oh, yeah. Go ahead. Yeah, I'll finish
it. I think we should both answer that one, because the term digital twin, it's a buzzword today. We all like to use it because it sounds cool, but it can mean different things to different people. A digital twin can refer to a three-dimensional CAD model. A digital twin can refer to a simulation model, whether that's a one-day model-based systems model, or it could be a full-blown three-dimensional model using finite element methods or CFD. But it doesn't only have to be that. A digital twin can also refer to an ongoing record, digital record of what's happening on the shop floor or on the production floor. So you can in a way think of an IoT system as maintaining a digital twin or digital copy of what's happening in real life. But the fact that you're storing that data gives you the possibility to do additional analyses on that data. And I'll have to remind me what the rest of the question was.
I can maybe also augment your answer, Chris, by saying that, you know, by combining real-time telemetry, whether it's from MindSphere industrial IoT system or any other historian system that you might have on-premise or in a cloud, with simulation data of that situation that's happening in real life, you can run you know, correlation between you know, real-time telemetry and simulated results that you're expecting, and then any deviation from it, you can build AI models to recognize the differences between what was simulated and expected versus the reality, and see if you have sensor drifts or other issues, and then recommend parameter to go back to a normal or bring back the external effect down so that it goes back to what you had simulated and predicted and wanted. And then over time, you might actually, you know, tweak your CAE models that were the original models, because they had all sorts of assumptions, whether you're in the thermal side or structural or manufacturing. Of course, there are always the ideal you know, simulation world upfront and design upfront, and then there's the reality, and you know, no matter how accurate you want your bolt connections to be in the structural model, there will always be differences, and whether it's because of material discrepancies or roughness that's not, you know, exactly the way it was modeled, you can then, you know, pinpoint those areas of parameters of the original CAE simulation model based on the normal conditions that you're seeing in actual real life, and that is stable and reproducible, and that can help you modify the model to get, you know, better and better at predicting in the future. And we use that technique also from a digital twin perspective to predict and forecast behavior and augment data sets. Often people come to us with the artificial intelligence project, deep learning project, saying, we don't have failure data. And we say, well, do you have a digital twin or simulation model of this problem? And sometimes they do, sometimes they don't, so we can build one for them. And then use that model to simulate failures. And that becomes a you know, a significant value add of having the digital twin model. Sorry, my long answer.
Thank you. What programming language are you using for the signal processing?
The signal processing app? Well, the app itself is it's a web-based app, part of the MindSphere platform. So we're talking about you know, JavaScript technologies, and I think we used Angular framework, if I'm not mistaken. The backend was Node.js, and there was another backend that wrapped our actual signal processing algorithms, which was Python based. But the point that I think I was making back on that slide is that we were using the if I can say it, the lower level coding languages. They're not really that low level, but actual coding languages to build the app and deploy it on the MindSphere platform, which is certainly possible. The advantage with no-code, low-code environment, which is why we're making the point about Mendix, is that you don't have to be coding the JavaScript. You don't have to be coding the Node.js. You're basically using a purpose-built UI-driven development environment, either native on your machine or on actually Mendix Designer is on the web, and it's much quicker to build a web app because all of the coding and infrastructure happens behind the scenes. But to answer your question, those are the technologies that we use. Yeah.
Awesome. So we only have time for one more question. This question is, can Mendix connect to simulation tools such as ANSYS, Abacus, and how is it done? Do we need to write connectors?
Well, the answer is yes, because we've shown it working with SimCenter 3D. Was the example, the last example from the talk, connecting to other simulation packages, ANSYS and Abacus. I'm going to say that most likely a connector is needed, but that's really just a way to actually launch the simulation tool. We're not talking about a complicated connection. I know a little bit about Abacus in the sense that you can script a lot, and by having a script that's going to launch, say, a parameter update and then invoke the Abacus solver, that can be done. And then as long as it's available as a service on a machine, like the machine that you want to run your simulations on, then Mendix can tie into it, because Mendix interfaces with web REST API calls and other technologies. Off the top of my head, I think there's like transfer technologies and SOAP technologies. Anyways, so as long as you have a minimal connector like that launches the simulations, then I believe that you can use Mendix as a way of interfacing with your digital twin developed using those other CAE tools.
Yeah, absolutely. I concur.
Awesome.
Thank you.
Thank you. Well, that's all we have for now. Thank you, Remy, and thank you, Chris, for providing us with great content and value today. And thank you, attendees, for joining us. We hope you'll return for future webinars. Bye for now.
Thanks so much, guys.
Thank you.